Calculus section 1.2, points and lines on a plane. This is covered earlier and we're just doing a quick rehash and what was learned in geometry or some such thing. If you have a plane, the plane in mathematics is usually divided into four equal parts with two perpendicular lines. They're called x and y axis. And you can have a point on the plane, and the points are denoted by two coordinates, x and y. X is the value down here, okay? This is the x value. And then y is the height. That is, over here, this is the y value. Now if you have 2 points, that is, let's say you have on the plane, you have point A and point B, and so we'll call it x1, y1, x2, y2. Let's say you have 2 points on the plane, and you usually want to connect it with a straight line for no reason. The distance between the two points is given by this particular formula, which is based on the Pythagoras theorem, which is you just figure out the distance of the two, I think they're called lakes, 2 lakes or whatever the sides are, and then square and take the square root. In this form, you will do something like x2 minus x1 squared plus y2 minus y1 squared and squared, and the whole thing take the square root. Now all these numbers on the bottom, they denote different x's, but the square on top means something else. It means to square. Now at first this might look kind of confusing. You have a 2 down here and 2 up there, and they mean something different. But once you get used to it, it'll become like second nature. But do not get intimidated by all the various symbols. X1 means the values from the first point, and then of course y2 means the y value from the second point. There are several equations of lines that is worth memorizing. The first sentence says the equation of a line that connects these 2 points, okay, is given by this particular equation, which says y minus y1 equal to x2 minus, equal to y2 minus y1 divided by x2 minus x1. That is called the slope. That is the distance of this height divided by the height divided by the separation. So that is called the slope, and that is also defined as the slope in real life, times x minus x1. Now in this equation, it's very important to remember x and y is a random point on here, okay? X and y moves around. It's not stable. I mean, it's not staying anywhere. Y2 and x2 is a fixed point, and so is y1, x1. That's the other fixed point. So y is the only variable. Y and x are the only variables here. The others are fixed numbers. And with all this stuff, you will be able to come up with the equation of the line. So these are the numbers that are maybe given to you, and then this will be the equation you come up with. And another way of saying this is that this thing is often called m. Okay, as a short form, m stands for slope. So then you can also write this equation as y minus y1 equal to m times x minus x1. And then the next thing is this equation can be further simplified to make it look like this, so that you can write it as y equal to mx plus a bunch of other stuff. What is the bunch of other stuff? Now remember that x and y are the only variables here. Everything else are constants. So then you multiply this out. Let's see. Plus, okay, we'll say minus mx1 plus y1. Okay, this bunch of stuff. I just multiply this out, and if you do and move this over, these are constants. Only x and y are the variable. So then this can be further simplified to be called mx plus b. And b stands for that pile of stuff. So then this is another form of describing the line. There are names for these equations, but the names are not that interesting. The point is, whenever you need one of these equations to figure out something, then you use the appropriate one. Now, there are two more theorems that we should mention. The first one is that if you have two lines, okay, if you have two lines at M1 and M2, then the two lines are parallel if parallel means if M1 equal to M2. So if you have two slopes with identicals, two lines with identical slopes, that means they're parallel. Okay, the slope is the same. The slanting degree is exactly the same, so the lines are going to be parallel. If on the other hand, the lines are going to be perpendicular, if M1 times M2, if M1 times M2 is equal to -1. So the two slopes, if they multiply to be -1, then they have to be perpendicular. And this is an if and only if situation, which means it goes either way. Okay, if it's parallel, the slopes are the same. If the slopes are the same, they must be parallel. If it's perpendicular, they multiply to be -1. If it multiplies to be -1, it's perpendicular. So the whole thing is completely connected. Now, let's do a couple of simple examples to see how this is done. For example, let's say we have something that, let's say you have a problem, okay, that says you have to have something that passes through the point 2, 1, x equal to 2, y equal to 1, and the slope is, let's say, 1/2. Then how do you do that? Well, you pick the formula that has a slope and a point in it. So this is a good one to pick from. So you have y minus the first constant, which is 1, equals the slope, which is 1/2, times x minus the second constant, which is x1, which is 2. And then you can clean this thing up a little bit, and that would be your answer. But in general, that's this kind of problem is very, very direct. So you just use one of these formulas and everything will come right up.